So today our topic of discussion is switch reluctance motor. Structurally, switch reluctance motor is almost similar to a variable reluctance stepper motor, but it has typical means few things are not common between the switch reluctance motor and variable stepper motor. In many book or many where you will find the application of this variable reluctance motor, they are the small scale motor, but we must understand the differences. The objective of my this particular lecture is to make you educate ourselves to understand the differences between two motors and when and where should we go for a particular one. Like in general, stepper motor, I am not saying that with stepper motor you can't have closed loop of application, but generally stepper motor is deployed in open loop mode. But in case of switch reluctance motor, that closed loop feedback is very important. Now coming to the structure, this is the structure of our switch reluctance motor. Here you can see that the structure. One thing I would like to mention that in switch reluctance motor, it depends on the working principle of this motor is like dependence of inductance on different path of reluctance. Means in a magnetic circuit, the reluctance directly affects the inductance, and inductance also affects the torque. So that is what this motor is all about, this variable switch reluctance motor. Now in switch reluctance motor, like first of all we must understand that what is the difference between stepper and switch reluctance. The main advantage offered by the stepper motor is the precision. What is that precision? Precision means it gives us a scope to adjust our angle. Like if I want even a very small step, I can achieve this with my stepper motor by increasing the number of rotor teeth. Now you must understand that if we want to adjust 12 rotor teeth, then for a particular cylinder bore of a particular dia, I can adjust it. Say for 12 teeth, I can take a 1-inch dia cylinder and adjust 12 teeth on it. But if I want 108 teeth on that same cylinder, then it would become difficult. Angular span remains 360 degree for all the cases, but it is not the angle, rather the peripheral length which you are getting if you are just increase the dia from 1 inch to 10 inch, then you would be able to, or means it will become easier for you to place 108 teeth on your rotor. Now, because we know that the formula, it is there, the rotor teeth is there in the denominator, and if we want to realize smaller step size, there is no way out other than go on increasing the rotor teeth. So in that way, variable reluctance stepper motor can give us a very high precision, or means a very small step angle realization is possible. But on the other hand, if you go for that realizing that kind of replacing 1 inch cylindrical rotor by a means 12 inch, sorry, 10-inch cylinder, obviously you are somewhat uh, occupying or means going for a bulkier volume. Now, when we are talking about this bulkier volume, it makes it is a very problematic things. So, when we are talking about bulkier volume, it occupies more space. But does it offer more torque, or means torque increase is proportional to the size? No. So what we can say that for high precision we should go to variable reluctance stepper motor, but if we want higher power density we must go for this kind of switch reluctance motor. However, unlike that stepper motor, even in stepper motor you can have odd number of poles, but in variable switch reluctance motor generally number of stator poles are even. So advantage offered by the switch reluctance motor is like it is very efficient. Very offering very good performance in terms of torque and inertia ratio. Generally more inertia means the higher the dimension, means like generally we are working with materials whose having density of that material is quite common in more or less cases. So if you are going for a means heavier machine, you are bound to occupy more volume. And also these machines where the weight is also a constraint. So space and weight of the machine means how bulky the machine is and how much it weighs the entire system. It all is a very crucial question in case of a small scale application. In case of power generation, all these are just obviously no one wants that you occupy unnecessary space. If a machine can have a means like axial length of say uh, 10 meter, if you want to occupy 20 meter for that particular purpose, no one will be happy. But whether it is sharply 10 or 11 or 9, that hardly makes much difference. So here these are the very crucial question in case of this uh, small scale machine application. And another advantage of this is it can operate in four quadrant mode. What is four quadrant mode? You can learn where it is in your drive. You will get a better understanding of this. In four quadrant mode, what is there? It is torque speed. Like in the first quadrant, whether the torque and speed both are positive, In the second quadrant, speed is positive, torque is negative. In the third quadrant, like this one is what? This one is known as forward motoring. This one is forward braking. Forward braking is a case where you just want to stop your motor. In here it is reverse motoring, and this side is your reverse braking. Now, in case of this variable reluctance taper motor, this is possible. Now, uh, let us start understanding how it works. So what it going to replace? This actually going to replace our conventional DC series motor for and variable speed induction motor drive for small scale application, because you cannot realize a very large amount of torque with this motor. And another, I cannot say drawback, rather it is a constraint of this machine. It needs a very efficient control algorithm to make that it happen. Now, the stator of this switch reluctance motor, we can it's built up by stacking suitably uh, punched silicon lamination to the appropriate length, and the stator has salient poles. These poles carries concentric windings, and here one thing we must not forget: the coils of opposite stator poles are connected in series, right? And this in connection should be made very very short. Now, here in the rotor there is no winding. This is an application of 6 is to 4. Here it is 8 is to 6, means it is the ratio generally we mention. Now, what is its drive structure? Just in a very, I've taken it from a book to give you a bird's eye view. We give DC supply to the power converter. That power converter is going to feed your switch reluctance motor. Then it also have a current sensor and signal processes. Current sensor, because in which way you are going to, because there is a chance you can understand that at means transient state this may draw a very high current, because means not high, I won't say that high current, but means because it's an inductor. But what I'm trying to say that it may have a tendency to during setup of initial flux, it behavior is not a very means you cannot predict it in a very straightforward manner, right? Now in switch reluctance motor, then the position sensor, obviously position sensor is or an encoder also, you can embark it on the rotor shaft, that will collect the data from the rotor, and then obviously you need position encoder data to be processed to your signal processing. Here generally encoder produces a signal that is not compatible with the controller, so you need signal processing algorithm here. Similarly, current sensor data also need to be processed through signal, and then controller here in the power converter, it is like that power electronic switches are there, and this controller typically controls the firing pulse of these power electronic switches, right? Just let me. Now to illustrate the working principle, I have taken SRM with 8 stator poles and 6 rotor teeth, or 6 rotor poles, whatever you want to say. Now this has 4 phases, just like that variable stepper reluctance stepper motor. These phases, we will excite them together with DC supply through these switches. Clear? Now, this A dash phase, we will keep it in active condition for a sizable amount of time. So, my rotor can align it with this particular position. Now, this particular position represents a stable equilibrium, just like that case of a stepper motor. And any disturbance to move our rotor from this particular position is or means will always be opposed by the electromagnetic torque to bring the rotor back in its position. Or any fluctuation, what it will do, just like that stepper motor, back EMF will be induced in this circuit, and that will be dissipated through stator heating. In next phase, this A dash will be de-energized and B dash will be energized, so it will rotate, and just like that stepper motor, the rotation will be 15 degree. So now what we can do is that if we can ensure somehow that or remove this mechanical constraint and keep on switching them in a periodic manner, like obviously these are power electronic switches, and you keep on switching them, then this rotor will rotate in a continuous fashion. Now clearly that inductance here will means vary in a cyclic manner. If you want to figure out how inductance will vary, probably or most of you are now revising the previous year that electromechanical energy conversion lecture. In that you will find that what we should do in case of a salient pole rotor, some problem I solved that time. You may go through that problem to figure out that how the inductance will vary in this case. So the phase inductance pattern will be like this. It will increase, then it will remain constant, then it will decrease. In that way it will vary. right? Basically, if you allow me to slightly abuse the technicality of this motor, then I would like to suggest that you can also read the working principle of your moving iron instrument. Whatever amount of torque is generated in moving iron instrument, I am going to show you that exactly same kind of torque will be produced by this switch reluctance motor. Okay, one thing that here we must understand why this variation is important here, that this variation depends on the amount of uh, overlapping what between the rotor and stator teeth. What is that overlapping means actually not some people call it overlapping, but I prefer to call it aligning. Perfect align, when these are perfectly aligned, then it is having minimum reluctance and then you can expect maximum inductance value. But when it is not there, then obviously, so if we consider from this stage, then first the inductance will be somewhat value, then gradually when the rotor will start aligning itself, then it will gradually reach here. Now once the rotor is here, it will remain here, and then it will be in this way. Now our task is to make sure that, like here, whether we will switch on after 1 4, if I suddenly switch on d dash, then what would happen means S4, the rotor was means from, and suppose the rotor was somewhere here, now it reach here. My objective is to make the rotor rotate in counterclockwise direction, but if I switch d dash, then the rotor will start moving in clockwise direction. So that kind of means reverse rotation we would want when we are looking for a continuous operation. So for ensuring that, what we need a few conditions to be means must be there. First of all, that number of rotor teeth and stator poles must be equal. Number two, the stator phase is energized now. How can you know that? For that you need a particular and very specific information collected from collected regarding your rotor position by that uh, rotational encoder or rotational means whatever you have mounted on your machine shaft. that must provide you a very particular information about your rotor position. So based on that, you can only change the sequence. Otherwise, if you do not have that information, then you will not be able to means the switching won't give you the desirable effect. Third one is in line with that. Fourth one is that the flux density is changing in magnitude and direction in the magnetic circuit when the rotor moves. So there is a chance of core loss. To reduce this core loss, what we should do is that we must laminate the rotor and stator structure. Here, the point is very important because if you do not do it due to eddy current, means high value of eddy current, this lamination cannot prevent your hysteresis, but lamination will surely prevent your eddy current. And when this eddy current will not be present in a considerable amount, then the heating of that iron part due to eddy current will be reduced by a considerable amount, and that reduction will help you to ensure better ventilation, or means make your cooling of the machine very easier, because as I said, all these are very small machine and of very compact shape and size. So here we don't have that, means what we rate for large scale machine, that some is having air cooling, hydrogen cooling, forced cooling. All this engineering you cannot do here, which is possible in a larger scale. This is not possible when your volume and weight of the system does matter. So here we must consider, or means we must be very cautious to cut down all the unnecessary source of heat generation. So now let me just write a few things. The torque production of SRM uh, is depending on winding inductance, and as I said that it is almost like your that uh, electrical uh, permanent magnet, sorry, not permanent magnet, moving iron uh, kind of things. So let us consider an SRM with alpha S is equal to stator slot angle, alpha R rotor slot angle, then beta is stator pole arc in degree or radian, beta R rotor uh, tooth are in degree or radian, then n is just a minute. So what we are having here, LRQ is the area of the air gap. Now the variation of inductance, we can study it here. This is the variation of inductance, right? So now if we consider the next picture, then you will understand that when the pole A and rotor tooth B, when the overlap begins, and then the inductance start increasing at this instance. Here you can see that inductance, this is the point of overlapping. Here you can see that where it starts increasing, and then this position, if we take it as a reference, theta is equal to 0, then we can have condition where our inductance reaches its maximum value when there is a perfect overlapping, right? So perfect overlapping is where you have the inductance value is maximum. A and B, they are perfectly aligned with each other, like this case, position of maximum inductance. and then what is happening, there is like here, that again the overlap starts decreasing, right, and here the overlap ends. Ends means almost there is no overlap. Now, obvious question that may comes in your mind is that what is there any constraint on pole arc and tooth arc? First of all, this is clear that when we are talking about this beta S is stator pole arc and beta R is rotor tooth arc. We can see when it is beta S, then it 0 to beta S it is here, then beta S to beta R it is here. Now we are interested to understand that is there any constant between beta S and beta R. Now let us establish a relation between our constants on pole arc and tooth arc. So uh, like uh, these constants are has to be satisfied for obtaining our, what to say, that optimum and feasible values for L max and L min. So for first building up of current in the through that voltage source, the stator phase should be switched at which instance? Whether when the inductance is maximum or when the inductance is minimum. The obvious answer is that when the inductance is minimum. Why so? Because if the inductance is minimum, then without you don't need much energy. The inductance will not play a key role. You don't need much energy to push through that inductor. The idea of inductor is what? It always tries to oppose the flow of rate of change of current. So if you try to flow the current while the inductor's value is at its peak, then you need a higher amount of voltage to circulate the current with same rate of change. But if you do it when the inductance value is small or rather minimum, then you need the minimum amount of voltage to ensure same rate of change of current. Why the rate of change of current is important? Because that is going to govern somewhere the speed and the performance of the machine. You cannot wait lifelong, so your inductor machine one stator pole will be energized, then it will do. It's not like that. So for fast building of the voltage source, current from that current from the voltage source, what we need is that when the inductor is minimum and constant. Now for that, what we need, Bs is less than alpha r. What is alpha r? Alpha is rotor slot angle or tooth angle. And what is Bs? That is stator pole arc. So what I am trying to say, that what it implies? It implies Bs should be less than 2 pi by nr minus br. So in a nutshell, it implies a condition that Bs plus Br should be less than 2 pi by Nr. This is one. This is required for rapid means for ensuring a proper rate of change of current. We need this condition. These conditions must be fulfilled. Actually, I should write it here. That is why I just draw a separation line so that you do not get confused. Then, another thing what is required, the stator slot angle must be less than the stator pole pitch. Another thing which is required, to avoid negative torque production, there must be a dual period during which inductance is maximum, and to meet this requirement we need Br greater than Bs. That means the rotor tooth arc should be greater than the stator pole arc. Once again, let us visit this diagram to understand this. So Bs greater than Br, right? And also you need to take care of that Bs plus Br must be less than this value. So see, in some way, this is, if you are looking for accomplishment of these objectives, you are somewhere putting bar or cap on the upper limit of Nr. This Nr, Ns, they cannot be very high, because if you make them high, then what would happen, that this will you will not be able to get this condition. However, on the other hand, if you consider the case of stepper motor, if you want a very precision step, you need all these to be very dense. Like you need more a higher value of NR. So these are the difference between the switch reluctance motor and this one. So beta S is equal to this is one. The, just a minute. Now, the another thing is that the period which L theta curve is positive, like this, let me write. It must have means the period So basically, which area we will finally occupy or utilize, that is, well, another angle must be drawn here. So combining all of them, the area which we will be getting is something like this part. Right. This is the actual working area which we can operate. Now, the torque equation, if we want to write the torque equation, in one revolution, the number of change for a phase is how much? Change means inductance change for a phase is NR. So energy converted into mechanical revolution per phase, NRW joules, energy converted mechanical energy developed then the amount of torque developed, so mechanical power developed will be the same value. Now how to find out the amount of torque? But in torque, what is should not be there, the value of omega. So this is the torque in Newton meter. And if we do it, what we will find from electrical angle, Pm will be half omega I square dl d theta, and T will be half I square dl d theta, the exact same formula that we use in case of our moving iron instrument. Only these formulas are required, derivation is not required. Now, one thing that is also important, that to increase the value of L max, because if we can maintain a high value of dl d theta, then we can produce a higher amount of torque. Not only I, but dl d theta also plays a crucial role. So how can we maximize the value of L? When these are aligned with each other, then we can means maximize the inductance by reducing the amount of air gap. Now the unaligned air means inductance should be as small as possible. So for that, we have to keep the air gap length maximum when it is not aligned. And in addition, we have to operate the magnetic circuit in high saturating condition. So this is all for switch reluctance machine. The objective of all this is not to discuss the drive circuit and all the details, but just to give you the hints that what is there and what are required for these machines. So you can select machine when you will read drive. You can select suitable machine for suitable application.